Previously, we've seen Jordan's lemma, which was about what happens when you have an integral over a circular segment, and then you take the limit of the radius of that circle moving towards infinity. Now you have many more of these limiting theorems, and what we will be discussing today are the so-called big and small limit theorems. So what's going on here? We're looking at the integral over CR of a function f of z dz, where just like before, CR here is this circular segment, okay, of a circle with radius r, a circle which originates at a point A. So again, very important, the integral here is only over this part CR, and it does not include these two straight segments over here. What are we looking at? We're looking at the limits of the radius going towards infinity. And then the big limit theorem will tell us that this limit is equal to j times alpha, and alpha being this angle over here, times a certain constant a, and that constant a can be calculated as the limit of z going towards infinity of our function f of z multiplied by z minus a. And little a again is the origin of the circle over here, the center of the circle. So this is the so-called big limit theorem, and we're just having it here without proof. Very important, when you try to apply the big limit theorem, people often forget when they calculate a here to multiply by z minus a. And that, of course, is a disaster. So don't do that. That's an integral part of this integral theorem over here. Also, do not confuse the big limit theorem with Jordan's lemma. They look very similar. They're both about these circular segments, but the integrand is different. When you have an integrand which involves a complex exponential, then Jordan is your friend. If that's not the case, Jordan becomes your enemy, and you should look at the big limit theorem. So don't confuse these two concepts. Title already says it. There's also a small brother of the big limit theorem, which is the small limit theorem. It will not surprise you that this is all about what happens when we take the limits of the radius going towards 0 of our circular segment CR f z dz. And in that case, that limit becomes j times the same angle alpha times a similar constant a. And in this case, the constant a is again calculated as the limit of f of z minus a. But in that case, we don't take the limits of z going towards infinity. We take the limits of z moving towards circle A, circle center A. Okay, so these are the small and the big limit theorems, and we will be using them all over the place very soon.